In this video, we're going to see some of the reactions that can be done by using alkynes as the starting material. The first one, and you've seen that with double bonds, is the hydrogenation of a triple bond. Just as in the case of double bonds, triple bonds can be hydrogenated by using H2 and platinum, palladium, and that will give us the fully saturated hydroalkane. So be very careful, because it's important that you recognize that here there are 4 carbons, same way that here there are 4 carbons as well, and when we hydrogenate them, we end up with the hydrocarbon chain. And so one thing that is important to note here is that the first alkene that it's formed is the cis one. The reason for that is because the hydrogen will approach the triple bond from the same side, meaning that both hydrogens will end up on the same side. This is a syn addition, right? Remember this? And that's why this intermediate, that it's not isolated in this case, would be the cis alkene. Then, so here we will use one equivalent to go to the double bond and another more equivalent of hydrogen to go to the sigma bond, to the simple alkane. Here we have another example. So when we have the double bond and we use hydrogen, remember we can use a variety of different metals here. So we can use platinum, palladium, nickel. That will give us the double bond, and the two H's come from the same side. When we have a triple bond, remember that this is like 2 sets of 2 pi bonds, right? So 1 pi bond will react first, giving the double bond, and then the other pi bond will react second, and that will go to the alkane. But sometimes we want to go from the alkyne to the alkene, not go all the way to the hydrocarbon. To do that, there are different methods depending if we want to get the cis alkene or the transalkene. Let's see them. The first one is we start with a triple bond and we treat with H2 and a poison catalyst. We'll often talk about the little r catalyst, this one right here. And so in the reaction, you will simply see little r catalyst. You will not often see this whole set of conditions. You should be able to recognize them, but we will often use little r's catalyst as the expression. So either with little r catalyst or this nickel complex, we can get the cis alkene. So just here, we start with a triple bond, we treat it with H2 and the nickel complex, or H2 and the little r's catalyst, and we stop at the cis alkene only. So this is a syn addition of hydrogen. Both of them come from the same side. But if we want to get the transalkene, we have to use another set of different conditions, and so that is by using sodium in ammonia, in liquid ammonia. And so I'm gonna let you think why water cannot be used here as a solvent. You may be aware that sodium reacts very, very strongly with water, so that's the reason why. So when we treat the triple bond with sodium and ammonia, we get the anti-addition of the two H's. So we will get one H here and then the other H here. You don't have to know the mechanism. It's a radical mechanism, and you haven't seen those yet, but you have to know that that's the way that we can get an anti-addition of the two H's across the triple bond and end up with the transalkene only. And so here we have a summary of all the reactions that we're going to see starting with alkyne. The first one is going to be the hydrogenation, the straight hydrogenation that we saw for double bonds, so nothing changed here. And so if you want the cis alkene, you will use H2 and little r's catalyst or the nickel complex. But I'm always going to be talking about the little large catalyst. And or the other option that you have is that if you want to get the trans alkene, just like this one here, you will have to use sodium in ammonia. Remember that this is cis because the two H's are on the same side, and this one here is going to be trans because your H's are on opposite sides. And of course, if you treat either of these alkenes with hydrogen and one of the metals, you will end up at the alkane.